Okay, so part 2 of 5-4, we're going to go back to the actual examples. So here we go. In this case, I am using the factors of 3 and the factors of 5 to make 2. So I have minus, minus, which means I have one of each. I have a y in each one. So I need to figure out what factors of 3 are going to combine with the factors of 5 so that when I take my outside times my inside, I get negative 2. So I'm going to make a list, my factors of 3, my factors of 5. Since I have one sign of each, I'm really subtracting outside minus inside. So my first and my last factors, and I start combining. Well, if I take 1 times 1 and 3 times 5 and I subtract them, I get negative 14. I could make it positive 14 by switching it around. That's not negative 2. So I need to switch them around. 1 times 3, or 1 times 5 minus 3 times 1 is 2. That's the number I want, even if the sign is wrong. So I need to pair my numbers in this way, except I need to flip it so the 5 is negative. So here's the negative position. The 5 has to be in the back term. The 5 needs to be paired with the 1 from the 3. The 3 goes over here by its y. It needs to be paired with the 1. So let's check our outside terms, negative 5y, our inside terms, 3y, negative 2y. That's what I want right here. Check your first two terms, y times 3y, 3y squared. Check your last terms, 1 times negative 5, negative 5. Now B, if there are only terms, the first thing you should always look for is greatest common factor. 2 terms, greatest common factor is all I have. So I have a greatest common factor of 5. I have a greatest common factor of m. And there aren't p's in both, so I can't do anything. When I take 5m out of the first term, I'm left with p squared. When I take 5m out of the second one, I'm left with 9. This is a difference of 2 perfect squares. So the 5m stays here. The difference of 2 perfect squares is the square of the first one plus the square of the second one, and the square of the first one minus the square of the second one. Because remember, 9 is really 3 squared. So it fits that pattern of a squared minus b squared. When I go to this next example, again I have 2 terms. Are there greatest common factors? No. The fact that these 2 are both cubed makes me take a look at this, that maybe I have my difference of perfect cubes. Well, 8, and actually I'm going to write this like so, because I know that that distributive, that's how that cube got on both pieces, plus 8 is 2 cubed. So really what I have right here is a cubed plus b cubed, which is the sum of perfect cubes. So a is my xy and b is 2. So then I go to the formula, and the formula for the sum of perfect cubes says to take the root, this value, of both of them and add it together. Then multiply that times the first one squared minus the 2 multiplied together plus the second one squared. Now all I have to do is a little bit of cleanup here and here to get it into a little bit better math grammar. And it's xy plus 2 times x squared y squared, so that's a distributive, minus 2xy plus 4. And that's how you factor the sum of perfect cubes. Now this one potentially is the difference of perfect cubes because it's a subtraction and I see factors of 3, but let's think about what I could rewrite this at. Well, 64 is really 4 cubed, and x squared is really x squared, or x to the 6 is really x squared cubed, and y I could break up into y squared cubed, because remember, a power to a power, you multiply. So I really could rewrite this as 4x squared cubed minus y squared cubed. So then what I have is that my a is 4x squared and my b is y squared when I go to use my formula. So my formula is my difference of perfect cubes, that one right there, or sum. So here we go with our difference, because that's what we're talking about. So the difference says the base of the first one minus the base of the second one times the first one squared plus the two bases multiplied together plus the second one squared. So again, we've got some cleanup here and some cleanup there. And so I have 4x squared minus y squared times, distribute this, 16x to the fourth plus 4x squared y squared plus y to the fourth. And that's how you deal with the sum and difference of two perfect squares. Those are formulas I'm going to give you for the test, so you just have to be able to apply them. Our last example is division by something that's crazy and not something that works for our long division. So quotient is a division. So another way to do division is you factor both your numerator and your denominator, and then you cancel. Now the reason we don't always do this is if something doesn't factor or if there's a remainder, it doesn't work out well. So that's why we also have the long division skills. So I'm going to factor the numerator. What two numbers minus minus, so I have one of each. I have an a in each one. So what factors of 6 are going to subtract, because my signs are opposite, to make -1. Obviously, 2 and 3 has to be this way because I need the 3 to be negative. Check your outside, positive 2a, your inside, negative 3a. Then I'm going to go ahead and I'm going to factor this one. Again, it becomes these two pieces, plus plus is plus plus. No coefficient in front of the a, so simply an a in each one. And this time I have the factors of 10. How are they going to add, because I have plus plus, to make 7? Obviously 2 and 5. The order doesn't matter. So there it is factored. I have two numbers in my numerator, two numbers in my denominator. Now, you can never ever cancel next to addition or subtraction. So if you have a plus 2 over a minus 7, you cannot cancel the a's because they're right next. Remember, these are single numbers. But if I have a single number that's the same, for example, if I have 3a times a minus 7 all over 9a squared times a minus 3, this right here can be canceled because it's actually part of a multiplication problem, and I can cancel away. So what happens right here is a plus 2 divided by a plus 2, those are the exact same numbers, they become 1, so they cancel, so I have a minus 3 over a plus 5. And that is how you simplify that. So that is the end of the 5-4 lesson.